Okay, 40 pre-cal, get ready to rumble here. Today we want to do a number of things with graphing of trigonometric functions. You guys had a tough assignment on section 6.3 that you just finished. Okay, but this concept of calculating the exact value of tangent is actually lesson 6.1, but we only evaluated sine and cosine for the purpose of your unit circle. So I want to spend a few minutes right now showing you how to calculate tangent. Okay, so what you guys should have in front of you is your unit circle, where we have all the sine and cosine ratios represented for each of the angles of rotation. And we want to now find out the tangent ratios at each of those locations. Okay, so how we're going to do that is we're going to focus here just on quadrant 1. So I took a picture of what's going on in quadrant 1. And just a quick recall here, and you'll want to write this down. Somewhere in section 6.1 in your book would be a good idea. We've already established that x is always equal to the cosine of the angle of reference. So we've already talked about that. And we've already talked about, well, y is the sine value of the angle of reference. So that's why, for example, at pi over 6 angle of rotation, at this angle of rotation of pi over 6, that's why the cosine of pi over 6 is root 3 over 2, and the sine of pi over 6 is a half, right? So we know that, hopefully. Well, today we're going to spend a little bit of time on tangent. Well, tangent, if we think back to previous courses, tangent theta, well, is the opposite over the adjacent using right angle trigonometry. Well, using right angle trigonometry, we could look at that another way. We could say, well, this is the opposite and this is the adjacent for this angle of reference. But it just so happens that that opposite side is the y value. It is always equal to the sine of the included angle. Right? That's what we said over here. So the opposite is sine theta, and the adjacent, which is the x value in this case, will be the cosine of the angle of rotation. So we can say that the tangent of theta will always equal the opposite, which is the sine of theta, over the adjacent, which is the cosine of theta, which in actuality is just the opposite over the adjacent, the y over the x value. So we have everything we need here in quadrant 1 to go and search for some patterns. So let's start here at 0 or 2 pi. Well, tangent of 0 equals the sine of 0, I'm going to do this the long way, over the cosine of 0. What is the sine of 0, Evan? Evan, oh, you're not here today. Okay, I'm showing you this in Winkler. Sine of 0 is 0. The cosine of 0, Cade, what is it? Quick, quick, quick. Did he say 1? I hope so. So the tangent of 0 is 0 over 1, and we know that 0 over any number is indeed 0. So I want you on your good copy of the unit circle, on the outside here, let's write down the tangent values, and I'm going to do it in red pen. Tangent at 0 is 0. Okay, next angle, pi over 6. Tangent to pi over 6. Tangent to pi over 6 equals the sine of pi over 6 divided by the cosine of pi over 6. What is the sine of pi over 6? Dawson. Did he say a half? It is a half. The cosine of pi over 6, the x value, what's that, Johnny? Root 3 over 2. When you have a fraction divided by a fraction, we learned in previous grades that you can multiply by the reciprocal of the denominator. So 1 over 2 times 2 over root 3 2's cancel in this case, and we get 1 over root 3. So tangent for a pi over 6 angle of rotation will always be, I'm going to write this in red, outside my circle, 1 over root 3. Okay, you guys do the same for pi over 4 and the last couple. Okay, so tangent pi over 4. You might be able to do this one without much work, because what do we know about pi over 4? What do we know, Owen? They're the same, Owen, right? They are the same. So I'm going to do all the work anyways. Wouldn't it be root 2 over 2 divided by root 2 over 2, which is clearly equal to 1. The opposite and the adjacent are the same for isosceles. 1. Write that on your circle. Evan, do you have the right book out? Okay. Pi over 4, now we're at pi over 3. Tangent to pi over 3. What do we write down? Sine of pi over 3. Cosine of pi over 3. Hambly, what's the sine of pi over 3? Did she say root 3 over 2? Cosine pi over 3. Gamiac. Did you say a half? Root 3 over 2 multiplied by the reciprocal of 2 over 1. Cancel, cancel. Root 3. Root 3, write that on your unit circle right there. Last one. Tangent pi over 2 equals sine of pi over 2 cosine of pi over 2 equals sine of pi over 2, Jessaroo, 1. Cos of pi over 2, Paige, 0, Paige. If you divide by 0, folks, what do we know? Can you divide by 0? You cannot. That's undefined. Infinity. No solution. Tangent is undefined at pi over 2, so I'm writing up here undefined. I wonder what happens at pi over 2 on the tangent graph, folks, if it's undefined. We'll save that for later. Okay, so we've got quadrant 1 done, and we're probably hoping for a pattern for quadrant 2. Why don't we find one value in quadrant 2 and see if there is a pattern? Let's go around this unit circle a little bit more. We've already gone right here to pi over 2. Let's go to here. What value is that in radians, folks? Did you say 1/6 more than pi over 2? Did you say 2 pi over 3? I hope so. So 2 pi over 3, we have x and y already. X is negative 1/2, and y is big root 3 over 2. But what is tangent? Tangent at a 2 pi over 3 angle of rotation is the sine of 2 pi over 3 over the cosine of 2 pi over 3 equals root 3 over 2, the y value, over the x value, equals, multiply by the reciprocal, leave the negative sign in the numerator, 2 cancels. Did you get negative root 3? Okay, so this is negative root 3 here for tangent. Put that on the outside. So, back to our nice clean unit circle diagram. Just to recap again, this was 0, small, 1 over root 3, medium, large, root 3, extra large, and infinity, infinite large. And 2 pi over 3, was that also root 3? But because it's in quadrant 2, according to the cast rule, tangent's negative? Hey folks, do you see a pattern? Do you see a pattern? Root 3, negative root 3. 1, 1 but negative 1. Tangent's negative. Would this be negative 1 over root 3 then? And wouldn't this be 0? Absolutely. Okay, 7 pi over 6. Let's go down here now. Look over here. Look, look, look. 7 pi over 6 is the same reference angle as 5 pi over 6. So that's also going to have a tangent of 1 over root 3. And because that's in T quadrant, tangent's positive. Small, medium, large, undefined, extra large. 11 pi over 6, same reference angle as pi over 6. Small, medium, large, infinity, extra large. But in quadrant 4, cosine's positive, which means tangent is negative. Make sure to mark those as negatives. Okay, so you've heard me kind of refer to my little trick for memorizing tangent. Tangent is small, 0. Medium, 1 over root 3 is a little bit bigger than 0. 1 is a little bit bigger than 1 over root 3. Root 3 is a little bit bigger than 1. And infinity is as big as it gets. So, small, medium, large, extra large, quadruple extra large. Some concept as to how that number is increasing. And then make sure you take on the sign of the appropriate quadrants in terms of the cast rule. Okay, so that video is going to help you with the graphing of tangent in 6.4 that we're also going to do today. This is a big day, folks. On Monday, I'm not reteaching any of this. You better know this. All right.